Exit ticket, January 5th, 2015, first day back from break, take one. Hello everyone, Mr. Sherman here. We're going to go over the exit ticket that we did yesterday on Monday. Many of you did very well, some of you struggled a little bit, and that's why we're going to go over it today. Please get out your exit ticket and follow along with me. If you can find your mistakes, do it. Okay, we learn by our mistakes. I make a lot of mistakes, so I've learned a lot in my past. So here it is. Here's the exit ticket from yesterday. All right, here we go. First, I'm going to write it down. We're going to please combine like terms, then factor. Combine like terms first, then factor. Okay? Let's write it down. 4x minus 3x squared. Plus 2xy plus 7x squared. Plus 6xy. Let's look at this. We've got kind of a messy expression here. We've got x's, we've got y's, we've got x's and y's, we've got all sorts of things. Let's try to make it simpler. Let's combine like terms. What do we do when we combine like terms? You look at the variable, okay? Coefficient, variable, coefficient, variables. All right, these are all terms. We have 1, 2, 3, 4, 5 terms in this expression. We're going to get it down to, right away, we're going to get it down to 1, 2, 3 terms instead of 5. Just simplify it, okay? We have 4x, that's going to add to the value of the expression. Minus 3x squared, that's going to take away. That's subtracting from the value of the expression. Adding to it, adding to it, adding to it, okay? We don't know the values of x and y yet. We're not going to find out the values of x and y. But you know what? We're going to make things simple so that when we're given the values of x and y, we can plug them in and it'll be an easy expression. Okay, here we go. Let's combine like terms. Let's look at terms that look similar. 2xy, 6xy. Looks a lot alike, doesn't it? Let's look at these. Can't we combine those? Don't they have similar variables here? Let's do that. And let's look at this. How about x squared? X squared. We have negative 3x squared and 7x squared. Okay? This is just the same as adding a negative number here. Subtracting 3x squared is just like adding negative 3x squared. So let's do that. A lot of you are having troubles with that. So let's add these two together. Okay, so we can go ahead and start simplifying. We're halfway done already. We can bring the 4x down. We don't have any other just plain old x variables in here. Let's bring 4x down. What would a positive 7x squared and a negative 3x squared equal? I mean, it looks to me like it would be 4x squared, wouldn't it? What's 7 minus 3 is 4. So we can go with 4x squared here, which is positive because 7x squared is greater than 3x squared. So we've got 4x squared. So we've already gotten rid of this, this, this. Now all we have left to do is combine those two. 2 plus 6 is 8, so we're going to have 8xy. Oops. 8xy. We've already combined like terms. All we have to do is factor. Look at this. We're half done. Combining like terms, we're half done. Now we're just going to factor. We've talked about factoring before. We've done the upside down Christmas or birthday cake, excuse me, the upside down birthday cake where we factor, 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 and we end up with something down here. Okay, it's going to look like a V. But let's just do it this way. Let's do it the simple way. Let's just look at the numbers first, and then we'll look at the variables. The numbers. What is the greatest common factor between 4, 4, and 8? What number will multiply evenly into each one of those numbers with no remainder? 4, wouldn't it? 4 goes into 4 once, twice. So, let's look at this. Do it like this. To start it off, it's going to be easy. We're going to put a 4 out here. Now, we factored 4 out of here, 4 out of here, and 4 out of here. Okay? What else is common with each one of these? Does each one of them have a y? This one does. These two don't. So we can't factor out a y out of each term. But we can factor out an x out of each term. If we take an x out of here, what's it going to leave us with? It's going to leave us with nothing. Okay? If we factor an x out of here, it's going to leave us with an x, because x squared is 2x's, is x times x. So we're going to take one of those away to put it out here. We're going to take this x away also. Okay? So let's take an x out of each term. Now, 4x times what equals 4x? 4x times 1. Doesn't it? 4x times 1 equals 4x. Okay? Now, 4x times what equals 4x squared? We know 4 times 1 is 4, x times 1 is x, but we still have an x here, don't we? What if we go like this? We put an x right here. 4x times x would be just like doesn't that equal 4x squared? If we do 4 times x times another x, it's going to give us 4x squared is what we want up here. So let's leave an x in here. Now, what do we multiply times 4x to get to 8xy? Well, you know that 2 times 4 is 8, so let's put a 2 here. X times x times 1 is x, so we can just leave a 1 there. We don't have to put anything there for that. And we know that we need to get a y in here also, because 4x times y would be 4xy, times 2 would be 8xy. So let's do that. We're done. That's it. We've gone from this expression up here to combining like terms, which we got right here, okay? Then we factored out a 4x out of each one of these terms and put it out here. 4x times 1 is 4x. 4x times x is 4x squared. 4x times 2y is 8xy. Okay? It's as simple as that. If you do it step by step, it really makes it pretty easy. Combine like terms first. Read the directions. You're going to have questions on the test coming up next week. They're going to have 2-step things that you're going to have to do with expressions. You're going to factor, you're going to distribute, you're going to combine like terms. You're going to do 2 of those 3 things with an expression. But it's going to be easy if you do them one at a time. Okay? All right, that's it for the exit ticket. I hope everyone understands, and I hope you followed along. If you made a mistake, which some of you did, I hope you found it and corrected it and understand what you did to make that mistake. Okay? We're going to do another one at the end of today's class, and it's going to be similar. All right? So I hope you understood this and followed along, and I will talk to you later. Bye.